Hi everybody, back to digital systems again. From the previous lecture, we talked about our problem. That's to create or do the circuit for the function a prime BC or BCD prime or BCD complement. And we talk about introducing the voltage inverter to your circuit to balance the line segment of the circuit, or for the same wire that's supposed to be the same voltage throughout the line segment. And we end up with the final circuit. Look like this. Okay, and also we talk about applying a NAND gate. NAND as N, and NAND as OR hardware. For this lecture, we will go through the circuit, and also I will show you how to work on PSPICE, or verify by PSPICE that we have the correct signals as we design. So maybe it's a good time for you to refresh working on the PSPICE. Okay, so first let's take a look at the truth table of the function. We have the function if we go to a prime BC plus BCD prime, or a complement BC, that's the AND gate, and OR with the BCD complement, this one also an AND gate. But we're going to use the NAND gate to implement the circuit. So first, let's do a straightforward, nothing to do with the circuit. So let's take a look at input. This is the high true. So you have input A, B, C, D, and the combinations, the total, that's going to be 2 to the power of 4th, right? Because you have 4 inputs. So that means you're going to have 16 combinations. For A, you start from 0, 8 of them, and then B, and then C, and then D. And this is your A prime, or A low true. And a complement BC, this is your A complement BC, and this is the BCD complement, or BCD low true. And then you put the OR gate, and then you finally you have the function f, as shown here. So you have only 0 or low, only 1. Okay, that's the truth table for the function if you works straightforward. Now let's take a look at your circuit. This is your circuit, right here. So you're going to use the NAND gate to implement the circuit. So basically this is your NAND as the AND, and this one also NAND as AND, but this one NAND as OR. Okay, we worked on this before. NAND as the AND, or NAND as OR. Okay, you can look back to the previous lecture. Okay, here, so let's go to the truth table for the circuit. So this is sorry, I need to show you the truth table for the circuit here. By comparing the circuit and the truth table, okay, here, this is my circuit. Let's minimize. Because some of you probably confused about the circuit because you not really use the this is supposed to be AND gate, right? But we use the NAND gate as AND gate, as well as this one. We use the, instead of you use the OR gate, we use the NAND gate as OR. So from the circuit, same, you have input, and what happened is that you're going to sorry, hold on a second. Okay, and this is what you have starting from the left of your circuit, or the output of G1 for G4 actually is do this work for a prime or a low true, and then for G1 it's going to do work for a complement BC, right? So this is actually pin 12, as well as the G2. This is the become the AND gate for 3 input B, C, and D. So you have B, C, and D, and the inverter, the voltage inverter, actually do the conversion work. So that's turned out to be your BCD complement. So this is what you have. And then for G3, that's going to be this one as NAND as the OR gate. So you simply OR A prime BC with BCD, right? Because actually this one is BCD complement, but since you already add one voltage inverter to the line segment, so this turn out back to be I'm sorry, so this one supposed to be BCD complement. Sorry, my mistake. So when you add them together, you see that you will have 1 or 1. Let's give you 1. So wherever you have 1, let's give you output to be 1, except both of your input are 0. So this is your A complement BC, and this is your BCD complement. Okay, so let's give you 0, only 1 for your output. Actually, from this one here. Okay, so when you compare to your work for the function, A prime BC or BCD complement, and that's there. I have the table. Just want to compare. It's supposed to be this page, and this is what you do, or straightforward. for A prime BC and or B or CD or complement. Okay, let me get this one back. As you can see, alright, sorry, step forward. Okay, so you have the same output. You have a 0 right here, and you have only 1 0 right here. Okay, I hope you understand. You compare the truth table directly from the given function, and also from your circuit, or you use the NAND as AND and NAND as OR, right? So this one you're using IC 74 HC or what 10, right? That's the 3 input NAND gate. But for G3, since you require earlier to input, you simply short the pin number 9 and number 10 together, and then for 3 input NAND gate you end up with 2 input NAND gate. Okay, so that's about our truth table before we move forward to do the PSPICE simulation. Okay, this is my circuit. Just take a look quick. Why do I have 2 circuits? I just want to compare when you work straight. This is you work straight for your circuit. You have function of what? Sorry, F equal to, let me blow this up so you can see clear. When you work straight, you want to implement the circuit for the function what? A prime, B, C, or B, C, D, complement, right? And then you are together. So you get your function F. That's you use the normal case, just look straight. When you have AND, you use AND. When you have OR, you use OR. But for our work, we use only what? NAND gate, right? Okay. So this become NAND as AND. And this one also the same, NAND as AND. And this one, NAND as OR, right? So let's see if you will get the same result. So let's do the fact that you want to do the circuit. Okay, this is let's work this out first. For the circuit, just reflect your PSPICE. This is the 3 input AND gate, or 7411. To get the part, you simply Control G, right? Or you can go to draw and get new part, or Control G. This is your Control G. So your part is going to pop up and remind you again about if you want to see what is the 74351. You simply scroll down, or whatever the numbers show up, so you see the symbol to see what is it. And for you're looking for 7. Oops, sorry. So you're looking for 7411. That's the 3 input and gateway. So simply you type 7411. That's going to pop up. So you just hit the place. Left click to place. Right click to stop. Okay. So that's how we get new port. I just simply control Z to undo. Same as the voltage inverter, you simply type 7404. And to do the wiring, you go to draw and you see your wire, or you simply hit Control W. Left click to start doing the wiring, and left click again to change the direction, and stop by clicking the right click. Okay, so I Control Z to undo. Now the main part is that how to do the digital clock corresponding to your truth table, because you want to compare it to your truth table, right? For this case, you want sorry, hold on a second. Okay, so for your input, you have A, B, C, D, and you have a total to the fourth rate. You have 4 inputs, so that's make 16. So this is your A input, and this is your B input, and your C and your D. So actually the period, if you want to create a clock or digital clock, you need to divide it, in fractions. So for A, you may put this 1. You start from D, 0 to 1. You may put the off time to be 1 second, on time to be 1 second, or your period is going to be 2, right? And for C, on time going to be 2 seconds. Off time. On time going to be 2 seconds. For B, off time going to be 4 seconds, and on time going to be 4. For A, this on time to be off time to be 8 seconds, and on time to be 8 seconds. Okay, so that's how we do the digital clock. Let's go back to your circuit here. And then because I don't want to just want to save the time, so I will redraw the circuit. For a digital clock, you simply get new part, Control G and DIG, DIG, and you can see this one is digital clock. Okay, you just place, left click to place, right click to stop. Okay, to rotate, simply Control R, right, rotate, and F, that's flip. Okay, I don't need this one. Let's get back to our digital clock. So it's set up this one to be your input A, B, C. To do that, for a digital clock, you simply double click on the ST. Somehow this one does work, so I can go to alternate way to change. You go to edit, you go to attributes, and simply type this one as input A. Okay, so that's why you are going to have our label our input as A. So I don't need this one, I delete it. Now to set up the digital clock, you double click, or go to edit attribute. So on time it's going to be 8 seconds, off time going to be 8 seconds, total going to be 16 seconds, right? For B, your period is going to be half of a period of A. So you go to edit, you go to attribute. So that's why I have on time to be 4, off time to be 4. Same as there for C, you go to edit, this one going to drop, the period is going to be only 4. You have on time to be 2 seconds, off time to be 2 seconds. Okay? And now the next step is that since you already draw the circuit, you already have what? This there creates a complement, right? The voltage inverter, and this one simply NAND as N, as well as this one NAND as N. So the next step before you do a simulation, you need to go to setup. You go to analysis, and then setup. You select transient. Since there you want to see the whole signal or your digital clock, the final time I just put like 20 seconds, right? Because the input A go from they have like 16 combinations, and each combinations take 1 second. So I put like simply 20. That's enough. You click OK and you close it. Now you can go to simulate. Okay, you have no error. This one going to show you only a current. So that means you complete your simulation, and you go to the plot. You want to check if you have you want to see the input A, input B, C, D to see if it's correct. You go to the plot, and for your input A, it's just right here. Actually, it's the A, right? This is your input. See if I can. No, I cannot change the width of the layer. So let's see. You have for A input, you have 0. Each division is what, 0.5 seconds, right? So this one 0.5, and this one is 2 seconds. So A is going to be what, x0, right? 1, 2, 3, 4, 5. Oops, sorry, 5, 6, 7, 8, and become 1 for 8 seconds. You also be able to see B1, right? That's the input. Click OK. This is your B input. Also, you can see you see input, and the last one is what, the input. Here we go. All right. So you already have 4 inputs, and now you want to see your output, right? That's the final output, or the function of what? A prime, B, C, or with what? B, C, D complement, right? And you add them together. So you want to see the final output. So that's going to be what? G3 Y. Actually, they did not put like 12 over there. That's like A, B, C, and Y for PSPICE. So you look for G3Y as your output. You go to the plot, and then you go to G3Y, right here. You click OK. So by comparing with your Okay, truth table. You can see that you can use either table in the truth table. Sorry. Okay. Oops. Here. As you can see that your output is there become 0 for what? The last one, right? Your output is 0. And you go to check your input. So it's from this is A, B, C, D. So it's from 1, 1, 1, 1. Let's give you output 0. You go to check. So all input are 1, right? You can introduce your cursor here. This is very nice about PSPICE. If you click on the segment, this will show you the logic of your input and your output. So you want to go to these three because you are what? Output is only 0 here. You just simply double click. Just click left click on this one. You can see that this is from your input 1, 1, 1, 1. Let's give you output 0. Okay. You can take a look closely, you know, around each output of your circuit. That's how it's worked. And if you want to compare to your this is the original circuit. Since you already put like A prime, B, C, and you AND, right? You don't need NAND kit. You just simply use the straight AND kit. This also are AND kit, and this one instead of using a NAND as OR, you would simply use the 2 input OR kit. That's the 7432. So we will check the output, what? U8Y, right? U8Y. So you go to the plot, you add the plot. That's the U8Y. It's right here. You click OK. See that you have the same, you know, our digital clock for both circuits. Okay, you can play around with the circuit. Since we need to verify your design of your circuit with PSPICE simulation, they all have to match or have to agree. So that's all about how to design the circuit. We're starting from problems, right? Here, that's the function we're looking for, and you draw the circuit. Simply do 4 steps as I explained before, and then you end up with the circuit, and you do the drawing. Okay, again, this is you use NAND as AND, NAND as AND, and this is the NAND as OR. So your circuit, you use the all NANDs, right? 3 of them to implement the function. Okay, so the benefit or the advantage about this design is that in case you don't have an AND gate or OR gate, but you simply be able to use an AND gate. That's the alternate way to implement the circuit. Okay, so that's about my tutoring for this series. So we do more problems in next series. Okay, bye.